Hello friends, welcome again. So this is the session 11 in the complete SQL playlist, and in this session we will talk about joins, which is a super important concept in SQL. Joins. So in this session we will understand what is a join. We'll see it practically, the various kinds of joins which we can do. I won't give any definition as of now. We will see practically that what we wanted to do, and then we will take it more theoretically later. Okay, so you know that we have two tables. So I will say show tables. I have courses table and students table. I'll make a note here. So I have courses and students. These are the two tables I have. Okay. Now what I wanted to do, I wanted to find that okay, I know there is a student named Rahul. I want to understand in which course he has enrolled. I want to understand. So my problem statement is I want to know in which course Rahul has enrolled. If I want to do this, how do I get this? In my students table, I have my student F name, first name, that is, I can get Rahul from there. And here I have selected course. Selected course. I will just show you the table. So I will say select student F name, comma, selected course from students. So we can see that okay, Rahul has opted in for a course with course ID 1. Selected course ID is 1. That's what we understand. But we do not get what is the course name from here. Course name is something which is kept in another table, which is a courses table. So let me go back to my notepad. So we have, so example of this is we get Rahul, comma 1, which is the course ID, but not the name. Now we have another table called as courses table. And in this courses table, we have something like, so I can do a select star only, select star from courses. And we can see course ID 1, big data, course ID 2, web development, and so on. Now, course ID 1 is big data course we get to know from this table. In the previous table, we were not having this mapping information that this course ID 1 mapped to which course name, right? So, we have course ID, comma, course name. For example, 1, comma, that is big data. So basically, this is how the information is laid out in both these tables. Now you can clearly see that there is no way that from one single table we can get these details. We have to somehow get information from both these tables in order to tell that Rahul has enrolled for which course name, not the ID, which course name, right? I want to tell Rahul has enrolled for big data course. No single table is self sufficient to tell that to me. So what we need to do, we could have done it in a very tedious approach. What can be that tedious approach? I can say select, select, selected course. This one, selected course from students where student F name equal to Rahul. That means I can very well do this. In the students table, I can say, okay, where name is Rahul, can you tell which course ID he is taking? Course ID is named as selected course, right? So select selected course from students where student F name equal to Rahul. So basically we are saying, can you tell me the course ID in which Rahul is enrolled? And we get the answer as 1. Now what we will do is, we will write a query on top of it, select. So that means 1 is something which we have now. Consider this will be replaced by 1, right? Now we will say select course name from courses, because here the name is course name, right? Select course name from courses where course ID equal to whatever this is, and this would nail down to 1 actually, right? So I can put this in parenthesis this way, and this will give me the answer as big data, right? So this is kind of a nested query that we have written. You can check this out. So basically this eventually will give answer as 1. First this will be executed, and then it executes select course name from courses where course ID equal to 1, and this will give us the answer as big data. Let me try running this and show you the results. You can see this. Now what if we want the same thing for multiple people? Then we cannot keep on writing this query again and again, and it's a tedious approach, not a right way. Like we could do it, but what we could have easily done here is we could have joined these two tables so that we can see the complete view together for all the students, that this student is enrolled for big data course, this student is enrolled for web development course, and so on, right? So let us see how we can join two tables based on one common column. There should be a way based on which we have to join, and we join two tables based on one common column. Now, if you see this case, what is the common column? Selected course and course ID. Need not be that the column names have to be same. It's not the case. The names can be different, but you logically understand that I can join these two tables on these two columns. So, in students table, we have selected course, and in courses table, we have course ID. So the join will be happening on course ID and selected course column. So let us see how do we do it. Okay. So let me try writing a join query. What I can say, select, I can say student F name, comma, student last name, L name, comma, let's say I will say course name. All these three columns I am getting from all these. So the first two columns I am getting from the first table, and this course name I am getting from second table. Now I will say from students. So I am saying these two table columns are coming from table 1. This column is coming from table 2. When is this possible? Whenever we do a join. So definitely I have to give two tables name here, two table names here. From student, join, what is the other table name? Courses. That means we are saying we want to join two tables. One table is student, another table is courses. Actually, students table. Now, on basis of what column you want to join these two? On students dot selected course. You can see this. In students, we have selected course. So we are saying students dot selected course equal to courses dot course ID. Courses dot course ID. I hope this is clear. And just, I mean, in our case, these two columns are very well defined in table 1, and this column is defined in table 2. Just to make it even better in terms of readability, visibility, and even to avoid any confusions, we can just say students dot, because we know this particular column is coming from students table. Even this column is coming from students table. This column is coming from courses table, like this. So select students dot student first name, students dot student last name, courses dot course name. From students join courses, these two table we are joining. On, then we have to give the condition students dot selected course. That means selected course column is there in students table and course ID column is there in courses table. Based on these two we are joining. Now let me just pick this and try running, and we can see this, that we are able to get the result. With this we know, oh, Rohit has enrolled for web development course, Virat has enrolled for big data course, Shikhar has enrolled for data science, and so on. I hope this should give you a clear idea. Now whatever join we have performed, we have not mentioned what kind of join we are performing. By default it is a inner join. By default it is a inner join. What is inner join? Basically, in such a join, only the matching records fetches results. The non-matching records will not be considered or will be ignored. What I mean to say is, I will tell you what I mean to say. I will say select student F name from a selected course from students. Select uh, select course ID from courses. Now we can see in courses table we have 4 courses, 1, 2, 3, 4, and here we have 1, 2, and 3. That means we know that only a match is possible for the 3, but fourth one there is no match, because no one has taken up the course 4, or no one has enrolled for course ID 4. What was course ID 4, by the way? Let me say select star from courses, data structures. So you will not see data structures anywhere here. You can see it's totally eliminated. So you will not see data structures anywhere. Let me just show you. If you just a second, where is that? Let me pick this query and run this. And you will not see data structures anywhere because only the matching records are taken. The non-matching records are eliminated. So this is what a inner join is. You can make a note of it. Only the matching records are considered. Non-matching records are discarded or does not come up in the results. I hope this is clear. Now let us try few more things. Let's talk about uh, let's say left outer join. I will explain you what is a left outer join. We have already understood our inner join. In inner join, only the matching records or the records which are available in both the things will be considered. Rest will be discarded. In a left outer join, all the matching records are considered. That means when in left table and right table there is a match, all those are considered. Plus apart from this, we have all the records the records or all the non-matching records in the left table which does not have the match in the right. That means a record which is there in the left table but not there in right. Right? Because these two are not matching then. Matching records are coming, but apart from that, whatever is there in left table which is not there in right will also be coming to us. So let me show it in a different way now. If I have to do this, we should have some extra records in the left table. That means someone who has taken a course where course ID is 5, for example. Right? That's what it means. Right now, if you see this, a person has opted for 1, 2, and 3 courses only. Course ID 1, 2, and 3. Now, all of this is there in the right table because we know in the right table, courses table, we have course ID 1, 2, 3, and 4. Now, we need to add one more record where we say probably course ID 5. That is one way. Or from courses table, let us try to remove something where course ID is 2. That means, let's say we are discarding a course where course ID is 2. We are removing that from our curriculum altogether or from our institute altogether. I do not want to conduct the course with course ID 2. How do I delete this record from courses? I have lot of records in courses, right? I have 4 records in courses. Course ID 2 is web development. My web development trainer has left, right? And I am discarding that course. I want to remove it from here. How to do? I will say delete from courses where course ID equal to 2. Now the moment I hit enter, it will give me an error. Why? Because we have a foreign key constraint which we have put. Because if we remove this particular record, then of course the record which is there in students table who has taken this course will get, obsolete kind of. So that is why we are getting an error as we have set foreign key constraint. If we would not have set foreign key constraint, we could have deleted it. So let me recreate both the tables, students and courses, without these constraints so that I can play around. How do I quickly do it? I have a students table. How do I make a copy of it without these constraints? Quickly, I can say create table students latest. I am creating a new table with the name students latest. I do not want to give any schema or anything like that. But what I can quickly say is as select star from students. What it will do is it will create a new table with the name students latest with almost the same structure as students, and it will copy the data from students to students latest. But that foreign key constraint and all will not be there. I hope this is clear. Same way we can do it for the courses table. I am creating a table courses latest. Now we have two tables, students latest and courses latest. And I should be able to delete something from courses table now. So what I will do is select star from courses latest. I will show you the data. Courses latest. Oops. Okay. Now I want to discard this web development course, let's say. What should I do? I have a delete query here. And instead of courses, I will say courses latest. Done. Now, what if I try to do a inner join. First of all, let me try doing an inner join. How do I do an inner join? I have this query. I will take it and then I will just change the name here, students latest, right? Students latest, courses latest, from students latest, join courses latest on students latest dot selected course, courses latest dot course ID. And this is our inner join which we have done earlier, but now we are doing it on different tables. And we can see here web development has not come in because the right table does not have a matching record. As simple as that. Okay. So now you understood that in students table there are some students which says that selected course is 2, course id 2, web development, but we have removed that web development course from the right table, which is the courses table. So let's perform a left outer join. How do we perform a left outer join? How do we perform a left outer join? We just have to give the keyword left before the join, just like this. Now let me try running this. And you can see here we have got all the matching records, right? These are matching big data ones because course id 1 is there. Similarly, course id 3 is there, that is matching, plus course id 2, which is there in the left table but not there in right. Some student has enrolled for course id 2, right? It's there in left table but not there in right. So what happens? We are getting that record, we are getting this record padded with nulls on the right, because of course right table does not have any data related to web development course, right? Course id 2 basically. So that's why we are getting a null. So what we have to say is, when we talk about left outer join, all the matching records from left and right table are considered, plus all non-matching records in the left table which does not have match in the right, padded with nulls. These are shown with null padding, which we have seen just now. Ideally, Rohit Sharma was there in left table and he opted for course ID 2. Course ID 2 was not there in the right table, courses table. That's why from right table, when we are doing a join, we are getting null because there is no information regarding that. Now, if you have understood this, the right outer join should also be very, very similar. Right outer join. What does right outer join says? Almost exactly the same. I will copy this definition and change it slightly. All the matching records from left and right table plus all the non-matching records which are there in the right table which does not have the match in the left, added with nulls. That means if the record is in right table but not there in left table, it will be showcased to us, where on the left side nulls will be padded. Now how do we run this? I mean, this is exactly the same way we have learned the previous join, the left outer join. How do we run this? Instead of left, we say right. Now, what are the records which are there in right but not on left? I think the course 4, which is, uh, DevOps course or data structures course. None of our students has enrolled for data structure course. So there I should see that in student details it should show me null, but course name is data structures. Let us see. So we can see this. all these are matching records in both the tables. This one non-matching record, you can see this data structures is coming from the right table, and null is coming from the left table, because left table does not have a matching record. I hope this is clear. So this is how we can try understanding that how this works. Now talking about full outer join. Full outer join. I mean, very easy to understand. It's something like a combination of left outer and right outer. In this, all the matching records are shown. All the matching records plus non-matching records from left plus non-matching records from right. I mean, it's equivalent to a combination of left outer plus right outer, basically. Now, just to let you know, in MySQL, we do not have a keyword like full outer join. In lot of other databases, it would be there, but here we do not have it. How to simulate that? We can do a union on left outer join and right outer join. That means if we take this query, the left outer join query, and then we say, if we take this query and we say union, and then we take this query, the right outer join, then we should be able to get the results. That means we are saying, can you please give us the combination of both, right? Union is basically when like we, so whatever results we get from this, think it, let's say we get some 8 records, and from this, let's say we get again some 10 records. It will remove the duplicates, but it will give us all the distinct records one time. So it will like combine these two together in a single result and give it to us. So we can see this here. So these are all the matching records which we would have got anyways as part of inner join, and as part of the left outer join we are getting this Rohit Sharma null, because Rohit Sharma has enrolled for course ID 2, right? But course ID 2 is not there in the right table, that's why we are getting this. Similarly, in the right table we have data structures, but no one has enrolled for it, that's why we are getting it as part of this. So all this is as part of inner join. This particular record is just because of left outer join, and this particular record is because of right outer join, and we have got all of this together. So this is the result of a full outer join. I hope this is clear. So what we have learned in this session, we have learned inner join, we have learned left outer join, we have learned right outer join, right outer, okay, and we have learned full outer join. Remember, for full outer there is no keyword as such in MySQL. There many databases directly support full outer join and then we can get it, but here we used a trick of union so that we can combine the results of left outer and right outer and show it. So this is what we have learned. I hope this is fine. And there is something called as cross join, which is not much useful, but I will show you. Cross join is, let's say, in your left table you have 4 records, in your right table you have 7 records. Then it will try to combine each record on the left table with every record on the right. So that means the number of records will be 4 into 7 equal to 28, which might not make sense, but if we are using it with some conditional thing later, then we can use it. But cross join works. It's a very costly join because each record on the left table will be combined with all records on the right table. So for example, I will show you how to do that. What I can do is, select, uh, select, let's say count star. I will show you how many records we will get from students, comma courses. 32. Now I will do a count star on students. That how many records were there in students? Select star from students. Oops. I will do a count star. Actually, 8 records are there, I think, but let's see. 8 records. So students has 8 records. Courses has, it will have four, definitely four, and that's why when we are using this cross join, we are getting 32 records. How to do a cross join? Simple. We can say select star from students, comma courses. Right, 32. Or we can even say select star from students, join courses. 32. That means we are using the join clause, but we are not giving the where condition saying, okay, this column we want to match and all. Last time what we did, we said this table we want to join with this table on, and then we were giving a where clause that, okay, students dot selected course equal to courses dot course ID. We are not giving that clause now. We do not have any clause, so everything will match with everything, kind of. Not much useful, but still good to know. So what we have learned in this session, inner join, that means only the matching records are shown. Left outer join means matching records plus non-matching records from the left table. And how it will be showing? They will be padded with nulls on the right side. Right outer join is matching records plus non-matching records from the right table. Full outer join means a union of left outer and right outer. That means a combination of results which is of left outer join and right outer join. Cross join is each record in the left table will be mapped with every record on the right table. Quite important. Joins are super important, and I think this would have given you some idea on what I am trying to convey. So with this, let's stop the recording, and I hope you like the session. Thanks a lot.